Hi guys, welcome to our lesson. So today we're going to be focusing on introducing functions and their inverses. So we're going to look at firstly what is the definition of a function and what are the components of a function and how does a function then have an inverse. But before that, let's just look at our roadmap of what exactly we're going to try and look at in this particular lesson. So remember that when we look at functions, we have different types of functions, mainly four, although there are more that we look at. But for now, it's the linear, the quadratic, the hyperbolic, and the exponential function. Now, the new thing that we are going to introduce here will be what we call the inverse function, right? So the inverse function will be like the opposite of a particular function, but we're going to define it in great detail. Then when we talk about the concept of inverses, we then need to introduce what we call logarithms. In short, it's just logs. So hence I wrote logs here. Then we're going to look at our notation as to how do we write down an equation of a function. So remember the keywords that we're going to look at is firstly, what is a function? One component of a function is what we call a domain, which at times they also call it the input variables, and the range, which normally at times they also call it the output, right? And then lastly, the function notation, which we're going to talk about. Firstly, a function will be a mathematical relationship between two variables, right? But the condition of this relationship is that one input must only have one output. So every input value will only have one output value. But there are two types of these particular relationships that we are talking about. One is called one-to-one function, and then the other one is called many-to-one function. To just show you what exactly is a one-to-one function, this mainly means that every input value has exactly one output value, right? So every input value has exactly one output value. And the every input value means that a particular input value has only one output value. Whereas with a many-to-one, it simply just means that many input values can have one output value. It will still be a concept of a function. This is normally what we call a parabola, right? Remember a quadratic function. You know that maybe if I have -2 there, I will have +2 there. There will be two input values, but one output value, which is 0 and 0 there. So that's what a many-to-one function is. But how do we then try to talk about these? We talk about them in terms of what a domain is. Now, with a domain, the thing that you need to understand about a domain is these are a set of all the input values of a function, right? So everything that we consider an x variable is called a domain. So normally it's written as x is an element of, and then you say which x values are there in that particular graph. But in that particular graph, where the x values are, it must be only where the graph is defined. Why am I saying defined? Because you will find that some x values are not part of the graph, and some y values are not part of the graph. Hence, where the y values or the x values are not part of a graph, we say that the graph is not defined there. Now, so this, we say it is a set of all input values for which the function is defined. We also say that the variable representing the input values is referred to as the independent variable, and also it is on the horizontal axis, which we call the x-axis in terms of our Cartesian plane. Right? Now on the y-axis is what we call the range of a function, and this will be the set of all the output values that result from the input values of the domain. So not anything else other than what we get when we use our input values. That's why we only consider it as due to having an input value to give us the output value. And then also the range of a function, we then consider it as a dependent variable. Dependent variable because it depends on the input value. For you to get the output, you need a certain variable, which is the input value. And then this on the Cartesian plane, we normally find it on the y-axis, which is the vertical axis. Now, the vertical line test, this is a visual way to determine whether a graph represents a function, right? So not all graphs that we have in mathematics represent a function. Remember a function, we said one input value must go with one output value, right? That's the goal. That is the relationship. Now, to see this, we use a vertical line test, meaning if a vertical line intersects the graph in all places at exactly 1 point, then we claim that the relation is a function. What do I mean? Let's say my graph is this blue one here, right, which is f of x is equals to mx plus c, right, because it's a straight line graph. If I draw a vertical line here, as I'm moving with my vertical line from left to right, you will find that it is only intersecting the graph at 1 point each time it intersects the graph. Only 1 point. After it passes, one more point, one more point, one more point. However, if this vertical line test then touches the graph or intersects the graph at more than 1 point, then we then say that this is not a function. And a typical example of this will be a circle, right? If you draw a vertical line on a circle, when it starts here, it becomes a tangent to this line, right? Because it is intersecting at only 1 point. But as soon as you move from left to right, it then now becomes intersecting the graph at 2 points, which we then consider this to not be a function because of that particular relationship. Now, function notation, remember this is how we represent the functions. We normally use f of x or g of x or h of x. It can be any letter. The x value, what does this mean? The output is the g of x, the h of x, and the f of x, right? Where the input value is x. So if your graph is in terms of maybe time and you use t for time, then you will say maybe h of t, right? Why? Because the t will represent the input value, which is your x value. Now, we have what we call an inverse function, excuse me. With an inverse function, remember that this is a function that can reverse into another function, right? What exactly does that mean? It means this is just a reflection of a function about the line y equal to x. What this means is that for you to find an inverse function, we denote it by f to the exponent of -1. You will see that some of the questions you're going to do, they will be introducing inverse functions as just f to the -1 without the word inverse. And this is how you look at the inverse function. What does this mean? It means that whatever that was an x becomes a y, right? And whatever that was a y becomes an x. And that's how you look at the inverse function. So in simple terms, for you to get an inverse function, what you need to do is to interchange the x and y. Some people use the word swap, right? You can swap x and y, meaning whatever that is x becomes y, and whatever that was y becomes x. And then you make y the subject of the formula, and then lastly, you write the final formula in the form of f to the -1 into x equals to whatsoever that you get there. And that's how you look at the concept of a function and its inverse. When we come back from the ad break, we're then going to look at some examples of how exactly do we do all of this that we've spoken about so far, and try to apply these concepts of what a function is and how do I get my inverse. Please stay tuned. I'll be back just now.